Welcome to the second season of Punching Cards. In these episodes, different teams of master's students who took part in a science communication course sat with experts and explored the latest insights in intelligence research.
By the Science of Intelligence cluster in Berlin, this is Punching Cards, the podcast about all things intelligent.
Everybody used it, also the Chinese companies, in every cell phone, and then it vanished. And now we are back, because I never believed that the transformer is a better technology.
This is Sepp Hochreiter, a pioneer in his field and the inventor of the long short-term memory model, short LSTM. The LSTM model was one of the first widely adopted large language models used in well-known language applications such as Amazon Alexa, Siri, and Google Translate. However, around 2017, his LSTM model was largely replaced by a new state-of-the-art technology called transformers, which is also used by Chat GPT. But Sepp is back, and he wants you to know that his new model, called the Extended LSTM, short XLSTM, has the potential to replace the technology that once replaced his original model. Hi, we are Sarah
and Julia,
and we created this episode together with our fellow students Elena, Gregor, and Erik. All of us are computer science majors at TU Berlin, and we actually learned about the LSTM model in our machine intelligence lecture last semester. Do you remember, Julia?
Yeah, definitely. It was in the lecture on recurrent neural networks, which LSTM is an improved version of. It's also crazy to think that Sepp Hochreiter developed the LSTM already in the 90s, which was for his diploma thesis at the Technical University of Munich back then. And his supervisor was Jürgen Schmidhuber, another well-known AI researcher.
That's right, and he also spent some time here at TU Berlin, where he was an assistant professor from 2001 to 2006 in the field of machine learning and computational neuroscience.
Yeah, right. Back then we could have learned about the LSTM from the inventor himself.
And in May this year, Sepp came back to TU Berlin, where he gave a talk about his new invention, the XLSTM. In the course of his visit, we had the honor to interview him and talk to him about why XLSTMs are better than transformers, what he learned from his first big launch of the original LSTM in the 90s and 2000s, what this has to do with mojitos from Amazon, and some other very interesting insights. Now let's cut to the chase and listen what Sepp had to say. Hello Sepp, welcome at TU Berlin again. You've been an assistant professor here for a few years, and we really appreciate you coming back to TU and that you're taking the time to answer some of our questions. First up, could you please introduce yourself in 1 or 2 sentences?
My name is Sepp Hochreiter. Currently I'm heading the Institute of Machine Learning in Linz, which is in Austria. And I'm heading other stuff like the Alice unit in Linz, Audit.co, Deep Learning Center, and some other stuff. I'm known probably because of a system I have invented in my diploma thesis.
Can you tell us a little bit about the system you invented?
It's called LSTM, which stands for long short-term memory. It took some time that this invention became the language model, was on every cell phone, was in Siri, Alexa, Amazon, Microsoft, Facebook, now Meta. Everybody used it, also the Chinese companies, in every cell phone, and then it vanished.
As Sepp said, the LSTM model was used by applications like Siri, Alexa, but it was also used by Google Translate. Its architecture was based on the LSTM model from 2016 to 2020.
But then a new technology came, the transformer architecture, which was developed by Google itself. And as of now, most of the recent large language models use a transformer architecture as a foundation. The best known would probably be the generative pre-trained transformer, short GPT, which Chat GPT uses.
And this transformer architecture has a few advantages over the classic LSTM model.
And because of a technology called transformer, which was better parallelizable, you could put more data through the model than with the LSTMs. The LSTM has a Scala has a very small single memory. This was good for abstraction because many things are mapped to the Scala value. But the transformer was much better in memorizing the right words, tokens, and so on.
So one of the key advantages of transformers is their ability to be parallelized, which speeds up training a lot. This is a huge reason why we can train transformer-based models like GPT on enormous amounts of data, making them really smart. But does this mean transformers are always better? Are there still good reasons to use LSTMs if we could somehow fix their main problems? To explore these questions, we spoke with Alan Akbik, a professor at Humboldt University who specializes in large language models and natural language processing.
I would say probably the main advantage of transformers really is scalability. Yes, transformers can process hundreds of words at the same time, whereas the LSTM requires to read each word individually, right? And so therefore you can scale these models up much, much higher. So if you're training foundation models, transformers are really a great way to scale up these models. With some caveats, so there are some advantages that LSTMs have as well. I would say the second major advantage, and that's a huge one really, is that transformers have been around for 5 years. They've been used by the research community and by the engineering communities for 5 years. And so we have essentially a huge amount of tools available, a huge amount of software available. And the research community has essentially been optimizing every single aspect of transformer models, right? And they're still doing it, right? And so there's just this huge advantage just of being an established technology that a lot of people are using. The third advantage is more technical, but there is essentially an inductive advantage that transformers have, which is called deep bidirectionality. And you can kind of think of transformers as models where essentially a certain chunk of words, let's say 500 words, are read at the same time. So you can think about it like a person who had way too much coffee, right? And is reading like all these words and the eyes are going back and forth and reading all the words at the same time. And that gives these models a certain inductive bias that is very advantageous. Yeah, so they can, certain types of tasks they can solve really well.
Thank you. And you already said that LSTMs also have advantages. Would you rather say that LSTMs have more advantages or transformers? And why?
It's a good question. So I would say they actually occupy very different places in the spectrum, right? So you have essentially, if we talk about scalability, right? So transformers are very scalable during training, but when you want to generate text, right? If you train your Chat GPT and you want this model to actually answer questions, generating text is now very expensive with the transformers. Whereas in LSTM, because they have a memory mechanism, they can essentially generate text at linear costs. And that's very, very cheap, right? A second advantage of LSTMs is that they actually handle long sequences much cheaper. So the scalability to long texts, yeah, so if you're looking at, so I said transformers can handle, let's say 500 words or maybe even more, right? But if you're looking at sequences that are much longer, like DNA sequences or really long books or stuff like this, then suddenly the costs actually explode because transformers are quadratic in complexity with regards to sequence length. And the LSTM actually can handle long texts much better, or much cheaper at least.
Could you maybe quickly describe what the main problems there were that were fixed from the LSTM with now the XLSTM?
Yeah, so essentially, I think one of the main problems that is being fixed is the scalability problem. So if essentially the transformer is scalable to train but not scalable to use, yeah, and the LSTM is not very scalable to train but it is very scalable to use, what we're now looking at in the research community are approaches that can do both, right? That are scalable to train and scalable to use. And essentially the XLSTM is a step in that direction. So they're essentially, it's more scalable than the regular LSTM, but it is still very scalable in applications. So they've kind of weakened the recurrency a little bit in order to pull this off to make it more scalable. So that's one of the big advantages of the XLSTM. The other one that I personally find very exciting is that they've made some changes to the memory mechanism. So LSTMs are essentially an approach. I mentioned this, they read a text word by word, right? Unlike the transformer that's seeing all the words at the same time, an LSTM will actually read a text word by word by word by word. So you can think of it like a really short-sighted person kind of scanning a text like with their eyes, right? And at the end, putting the book down and saying, okay, ask me anything, because they remember everything in their memory mechanism, right? And so in this mechanism, they've made certain changes with the XLSTM. It's a little bit technical, but it kind of influences the way the way information is actually absorbed into this memory mechanism, right? Whereas before, there was essentially a bounded gate that's bounded between 0 and 1, where 1 would be I learn a lot, and 0 would mean I learn nothing, from this word that I'm reading right now. But now they have this exponential mechanism that allows a model to essentially see game-changing information. Like if there's something that's so spectacularly game-changing that it changes everything that comes before, that can now be modeled with this exponential activation mechanism. And I think, personally, I'm super excited about it, because I would really like to see like how the learning behavior of such a model is now different from the original LSTM.
As we said, Sepp is back with the XLSTM model, the extended long short-term memory. But with a few tweaks and improvements, Sepp was able to solve the problems that the LSTM had and give it an update. So there's some hope for LSTMs.
Now we are back, because I never believed that the transformer is a better technology. It's a faster technology. It's from the technical point of view, it was better, but not from the functionality. And now we really were able to show it.
That sounds very exciting. Tell us, how were you able to solve the problems of the LSTM architecture?
I thought for 20 years how to solve something. The transformer looks at the whole sequence and can pick out the best match. XLSTM processes the sequence sequentially. And now it have to pick something out, which it might think it's the best, but perhaps later something better comes. It cannot revise the decisions. It cannot revise something it stored and say, no, it was the wrong thing I stored. I want to store something else. I found something better. I never could solve this problem. And with this exponential gating plus normalization, it solved.
Can you tell us a bit more about the X in XLSTM and how it's related to the improvements you made?
That's the second invention, the memory structure. We have a new memory structure where all the gating and all the dynamics in the LSTM now is applied not to a scalar, but to a whole memory, like a Hopfield network, a whole memory. Then X might stand for, I gave you now two invention, exponential gating plus large memory. X might stand for the whole architecture to integrate the new LSTM blocks, the one with the bigger memory, the one with the exponential gating, and the bigger memory has also exponential gating, into a large architecture. The X might stand for an LSTM within a large architecture. But at the end, we called it extended long short-term memory, because otherwise we have to say, yes, X stands for one of these things, but all of these things is cool stuff. It works and it's tried out. It's super cool.
Can you quickly summarize again, what are the exact advantages of XLSTM over the transformer architecture which GPT uses?
First of all, the transformer is quadratic in the context length. Context length means, for example, the prompt. What we did, for example, in our university is for doing exams, we gave Chat GPT a question, then the whole manuscript of the lecture, and then the answer of the student, and asked ChatGPT, is the answer correct? And here you see you need a large context, many words, because the whole manuscript is in there. And that what, the students try to trick us by using ChatGPT, but we also trick them back by using ChatGPT to rate their exams. and here you need a large context. Or if you give a manual for a car or for a coffee machine or whatever into the prompt, you have many words, you have a long string. And the transformer is quadratic in the number of words, in the number of tokens. XLSTM is linear in the number of tokens. And therefore we are faster, you get the answer earlier. We need less compute. We need less compute in terms of memory. We don't need so much memory, but we need less GPUs, less graphic cards. We can do it cheaper. That's one advantage. Quadratic versus linear. There's another advantage, and this is transformer only does pairwise interactions. You have a query, it's a new word, and the new word interacts with all words which were already seen, which words which are as in the prompt or which were already generated. But you do it only pairwise. You don't mix 3 words. And sometimes there are problems which are more complicated, where you want to mix up more than one word. And with LSTM, we can do more complex stuff because we can code the whole past in the memory, and the new word interacts with the memory, with all the words combined, and not with a single word. Therefore, recurrent neural networks are more powerful, what they can compute, than transformer or state space models.
Thank you. So you already said the computation would be quadratic in context length for transformers and linear for the XLSTMs, meaning less compute for the same length of a text prompt. I can imagine this would also be an economic advantage. What would you say are other main economic advantages of XLSTMs?
We in advance know how large our memory is. For the transformers, the memory increases. If we now do computation on the edge, on small devices, we can design it with the memory because we can fix the memory, and we are faster. We need less compute, therefore we can do it on less compute on the edge on smaller devices. Therefore, for industrial application or applications like cell phone, in the car, we might have advantages over methods like the transformer. LSTM can store this in the memory and do programming, but memorizing somehow the context. The transformer always has to go through everything. But I think it's somehow stupid what the transformer is doing if it's producing a text. It has to go, if producing a new word, over all words it has already produced. Would you do this? Now we have a podcast, we have an interview. Now if you ask me the next thing or produce the next word, you go over all our words from the beginning and then do a new one. Then I say something, then you go over all words and do a new one. Now you have this in the memory, you know already what we talked about. You have some context. Perhaps we forgot the exact wording, but we memorize what we talked about, what were the answers and stuff like this. That's what LSTM is doing. Much more how humans do language. And here I see a big advantage to in kinds of abstractions, especially in coding, but we have to explore it.
You already kind of touched on that with the applications for the industry or the cell phone in a car. Do you already know what your first product with XLSTM will look like? Will it be a chat application like Chat GPT, or will it be something else?
Probably something else. We would go, first of all, in specific applications, also in engineering and stuff like this, because the more B2B, more to other companies, because Meta, Google, they have very good connection to their customers, which are private users, which are single users. And we don't want to compete with them. We want to find our niche for the first product. We have already some applications, especially applications like code copilot for programming, because there you often have more complex interactions, or you need a memory. There are many coding copilots already, but I would say if the programs get more complex, there's more interaction of different objects, data types. We make a better template, perhaps with XLSTM, than some methods which are out there. But that have to be explored. It's only a guess.
Okay, well, that's interesting. If the XLSTM would be even better than ChatGPT with solving coding tasks, especially for us as students in computer science, this would be a huge help since ChatGPT often doesn't work that well for larger coding tasks.
So according to Sepp, XLSTMs represent a significant advancement in the field of generative AI and language understanding. To sum it up, the main advantages are that XLSTMs have a linear computational cost relative to the context length, which means they would operate faster and require fewer computational resources than transformers. This would make them less demanding in terms of GPU usage and memory, thereby reducing costs. And not only would they be more efficient, XLSTMs could model more complex interactions by encoding the entire past into their memory. Unlike transformers, which need to reassess all previous words to generate a new one, XLSTMs maintain a continuous memory of past words. I can imagine the research community would be very excited about those advancements. We turned again to Alan Akbik to find out how the XLSTM paper was generally received by the science community. Is he as optimistic about the potential of the XLSTMs as Sepp is?
I generally agree that programming languages are a great use case. And the reason for this is again this memory mechanism of LSTMs, where they can kind of keep track of certain things over long time periods. And if you have like a piece of code and you want to keep track of all the commands that have already been entered, this type of regular language that tends to work really well with LSTMs. So I would agree that this type of problem is a really powerful application probably for the XLSTM. But I'm also optimistic that we can do something with regular language modeling. So in my group, we're actually starting to try it with the XLSTM, so that the XLSTM could even be used for regular language modeling approaches, just like ChatGPT. Obviously, we still have to see if it all works, but I personally would be kind of optimistic that it could work here as well. And generally, I mean, obviously, the code has just been released, and it's not in the same state as, let's say, transformer code that's been around for 5 years, right? But yeah, we're playing around with it, and we'll share results hopefully soon.
What was your perception of how the new XLSTM model was perceived by the members of the machine learning community and by the science community in general?
Mm-hmm. Yeah, I would say it was extremely highly anticipated. So everybody was waiting for the paper and for the code to show up, because we're all very excited about it. Historically, of course, the LSTM was the first technology that was really used for language modeling. And so it was then came the transformer, right? And a lot of us, including myself, we started with LSTMs. So of course, we are very excited about this type of technology. And again, the inductive biases of LSTMs are really cool. And so everybody, I think, is very excited about the paper. So I would probably also say that the community is still super focused, laser focused really on transformers. So the community is mostly looking at still optimizing every last bit of the transformer architecture. So it will take a while, I think, before this really gets hold in most research groups. And this is kind of mostly like a tooling thing, right? Transformers, they have, like I said, years of advantage in tooling. So you can just use very well-developed tools, whereas the XLSTM is new. And so the tooling still needs to be developed.
Now that we addressed the technical details, we wanted to know from Sepp what he had learned from the publication of the original LSTM paper in the 90s, which was quite some time ago. We asked Sepp what he wants to do differently this time with the publication and launch of his new XLSTM model.
And then the hype began. Then Google, Meta, Amazon, Microsoft, Baidu, Alibaba, all of them used this thing. And a couple of things happened. First of all, one guy from DeepMind told me, if you have a new invention with LSTM, forget it, because we will set there 100 software engineers and take it. You cannot do research on LSTM anymore. I was not very happy. Another thing was, later we developed in Linz something else. It was a CELO, it was a new activation function. Then there was a conference in Los Angeles. The guys from Amazon flew in and said, hey, we flew in to shake your hands and congratulate you because we have $1 billion increase in the turnover because of your system. And then they bought us mojitos. And now I think, and it was actually, there were 2 mojitos. They have 1 billion against 2 mojitos. And the question is, can we do better with the new invention of XLSTM?
Well, 2 mojitos for the LSTM for Amazon making $1 billion with Sepp's invention really doesn't sound like a good deal.
Definitely. The company he founded, which he talks about and which he wants to bring the XLSTM forward, is called NXAI. And with the help of this company, he wants to keep the technology in Europe.
He further talked about the European mentality, how it's different from the American mentality when bringing a new idea or invention onto the market.
From the invention side, from the scientific side, we are super strong. Where we are not strong is to bring these new technologies into companies, to apply it, to make money, to exploit it, to make something out of it. I can tell you a story. We were in the United States, and there, if somebody has a super cool idea at the university, then they said, hey, I have a super good idea, perhaps I can make a company and make money. In Germany, in Europe, if somebody at the university has a super cool idea, said, hey, I have a super cool idea, perhaps I can become professor. And these are the different mindsets, these are the different cultures. The idea is always, yes, you invent something at the university and now it goes into a company. And the inventors are still at the university. That's wrong. I think much better is you have some invention, and then with your invention you go into the company because it's your baby, it's your thing, and you really help to make it to a product. But as soon as it is standard, it's a product, you're not interested anymore. And now you should have the chance to go back to university. In Europe, you always have to decide either I go into industry or I stay in university. And also with NXAI, we want to open everything. Some might work a couple of years in the company and say, yeah, now it's out, it worked or did not work, but now I want to go back in research. But I don't want to, I want to company my idea, my algorithm or whatever. But if something else happens in the company, I'm not so interested anymore. I want to do research. And we want to open this, going through and forth from company to basic research.
That's a very interesting elaboration also on the difference between bringing your product out there in the US and in Europe. We have another question regarding this. Do you think the European AI Act will make it more difficult to launch new AI technologies in Europe?
Indeed, I think so. I'm very scared because the AI Act is okay. I wrote emails through and forth with EU parliamentary guys. It improved, but there's one problem still, which is hurting the XLSTM, because in the AI Act, foundation models are categorized as high risk, because foundation models can apply. And XLSTM will become a foundation model. Even if it's open source, it's still foundation models, and foundation models are high risk, which would mean that because XLSTM is a foundation model, I cannot bring it on the market, even if we are better in Europe, and the Americans, Chinese have their models and they are already on the market. This would be frustrating that because of the regulation foundation model high risk, you cannot follow it up, while Meta, Google, and Microsoft, whatever, can bring their models they have already on the market. But still, it's until 2025 until this really is in place, and therefore we now building still these big models, but hopefully something changes that we also are allowed to compete on the market. If we have the better model and cannot compete, hey, how frustrating would this be?
So foundation models such as the XLSTM are large-scale models capable of performing various tasks, including generating text, but also images and audio. And since these models are considered high risk under the AI Act, they have to undergo strict testing for compliance with several security measures to eventually get permission by the government to release the model onto the market. This could potentially make the development of foundation models slower and more expensive in the EU compared to the US. So let's hope that the AI Act doesn't make it too difficult to bring the XLSTM onto the market. We will definitely keep ourselves updated on that.
Sepp also talked to us about what kind of future vision he has for the XLSTM.
I can tell you what would be my dream. I want to build a GPT kind of thing, a large language model for a company, where in this large language model, all knowledge of the company is in. How did they do the tax? What conditions have the suppliers? How long do the suppliers? Condition about the customers. I know this machine in my factory does not work. Where is the screwdriver in my factory? Because I have in my factory many experts. And if they retire or leave the company, all this knowledge is lost. And I want to keep this knowledge in the company. And if I can build a chatbot where all the knowledge, all the experts' knowledge is in this chatbot, then the knowledge built in the company stays in the company and does not leave the company. That is one of the dreams.
Maybe one last question, since we are a student and this is also a big topic at TU. What are your thoughts on using AI for university, let's say for writing papers or final theses? Maybe you also have 2 points of view as a professor and also as a founder of an AI company.
I already told you, students trick us, we trick them back. It's with every new technology, you should use it, and also the professor should use it for whatever, because it's like you would say in the university, now we don't use computers because blah blah, or we don't use electricity. This would not make sense. Of course, it's a new technology, but you have to think how to integrate it. Also, you have to learn to use it. Perhaps later you have to write Latin Chinese to your Chinese partner, how you use this Chat GPT kind of stuff. Perhaps you want to have some information about some fact. You have to learn to use it, but you have to be very clear about it, how to use it, what's possible, how to check that everything is correct, that not somebody says, I have written it, but ChatGPT has written it. But there are many things, for example, only to check whether ChatGPT has written it. I can tell you a simple trick. You give the text to ChatGPT and say, can you improve it? And if there are only minor improvements, it was already written by a ChatGPT. That's a simple trick you can try out. But I think it's a new technology. Students have to learn how to use it, but also the teachers have to learn how to use it.
Okay, so in Sepp's opinion, students should be allowed to use applications like Chat GPT, but also tells us a trick on how to expose if something was written by Chat GPT. So I guess he's also on the professor's side.
We have an opinion from Alan as well. What does he say as a professor? Should students and professors use AI in university?
Okay, internally, I would say use it. So I'm completely for students using ChatGPT to do assignments and even thesis works. And I'm also fine with research papers being co-written by ChatGPT, right? Because for me, really, it's just another tool. It's like, of course, spelling correction is kind of like maybe not the greatest example, but it's a tool like this, really, right? So students are writing text, and they're using a tool to help them write better text. But in the end, it's a human that decides which text to use and how to put the text together. So for me personally, I'm actually all for using it. At the same time, of course, there's a huge risk that people over-rely on these tools. I feel like I'm starting to see it in some respects with some programming homeworks that seem to be co-written by chatbots, right? And then when you actually ask students, so what is happening here in this code, sometimes the answers are a little bit fuzzy. So there's this danger, right? But it's on the responsibility of us, right? Of us as the users to make sure that we're still learning how all of this stuff is actually working and not to overly rely on it. But generally, I would say we should allow the use of these technologies.
Are you also using it as a professor?
I actually am not, yeah. So we are, like when we write our research papers or proposals, I generally don't use it. So my PhD students, for instance, are allowed to use tools like this. There's Grammarly, right, that people are using, and also this type of tool. I have no problems with it, yeah.
Okay, so that was our interview with Sepp Hochreiter, a visionary researcher who keeps on believing in his ideas, learns from his past, and plans to come back even stronger.
Yeah, I'm very excited to see what we will hear from him and the XLSTM in the future. As he mentioned in the interview and also in his presentation here at TU Berlin, that he still hopes to attract more investors for his company NXAI, so they can afford the computational resources that are still needed to test the XLSTM on an even larger scale. So we wish him the best for that, and who knows, maybe some potential investors are listening.
Yes, and maybe the next generation of the best AI coding copilots will be based on XLSTMs. Or, as in Sepp's dream, he will use the XLSTM to build assistants that contain all the knowledge of a company. This will also likely make the onboarding of new employees a lot easier. Either way, we will hopefully all see the benefits of XLSTMs in the future.
Thank you once again to Sepp for the interview, and also to Professor Akbik for providing additional insights as a fellow expert in the field.
And thanks to our fellow students Gregor Voigts, Erik Rubinov and Elena, who were responsible for the production and editing of this podcast episode.
This podcast was created as a part of the lecture Communicating Hot Topics in Intelligence Research by Nicolas Roth and Benjamin Lang.
You can find and follow our podcast on Spotify and Apple Music and all your favorite podcast platforms. For show notes, links to additional material, more information, and to contact us, visit www.scienceofintelligence.de/punchingcards.